Alright guys, welcome to the video on factoring. This is going to be a review of things that you've learned in Algebra 2, and we're going to be going through some examples, and feel free to pause where you need to take notes on anything, and if you have any questions, write them in the margin and I will be more than happy to answer them. Alright, so first start off, what is factoring? When you get done factoring, each factor is prime. What that means is you can't take anything else out. And so when we look at things that are put into factored into primes, you know, it's a process where we're taking out everything that we can. And so, for example, if I've got a product and I end up factoring it, it looks like this. What we end up with is two factors that we can't take anything else out. And so you have to be looking for the patterns that are going to tell you that you haven't factored it all the way. Sometimes you're going to have two sets of parentheses, sometimes you're going to have three. Okay, so that's all part of the process. Go ahead and pause and write these rules down because these are going to be huge in helping us to shortcut some of these factoring examples. And especially today we're going to be looking at, you know, recognizing this, using this one, and then these I believe are going to be the most familiar to you, and so you're hopefully going to be able to use those pretty quickly when you recognize those in a problem. Okay, so go ahead and pause, write these down. They're going to be huge for you to reference during working on your notes. I'm going to go ahead and go on, but you go ahead and write those down. Let's do a couple of examples. When we're looking at this first example, it's saying factor the expression, and so what I'm going to try to look for is a common factor, and I notice that if I look at the three numbers in the problem, the coefficient and the two coefficients and the constant, I notice that I can factor out a -4. Well, then I'm going to have three terms in there. It's the reverse of the distributive property. And so what I'm going to be left with is an x squared, and I'm going to have. And so when we look at this expression, we've got a -4 that we can take out of that one. And as we're factoring out from this middle term, we need to make sure that we take into account the positives and the negatives. So -4 times -3 would be a +12. And then at the end here, we're going to have +4. Okay, and so when we're looking in here, we can see that we have something that we could factor out. For the second one, even though it's not written in standard form, still a common situation. We can take out a 3, and then we'll have 1 minus 4x squared. And what we can recognize now, hopefully, is that, you know, we have two perfect squares here. And so what we can end up doing is we can take out another factor, because we could rewrite this as 1 minus 2x squared. Let me rewrite that. 1 minus 2x squared. And so this is a case where we're looking at finding other things that we can factor out. And so as we do this one, we need to take a look at factoring out this difference of squares here, like we talked about that rule. So we're going to have 1 minus 2x and then 1 plus 2x. And this situation here is a difference of squares. Meaning we've got the difference of two values that could be written as squares. Okay, so that's a situation where we ended up with a lengthier answer, even though at first it looked very, very simple. So be careful to factor all those things. In this case here, what we're looking at is we have two values that are squared and a difference. So we're going to be using difference of squares again. But what we're doing is we're using one of the factors that is going to be an expression. And that's okay, because we're looking at difference of squares, and they just happen to be one of them is an expression, and one of them is just a y. Okay, so this should be a minus here. And so this, x plus 2 and x plus 2, they're going to play the role of our a term, and the y is going to play the role of the b. And so recognizing those difference of squares situations is really, really huge. Let's look at this next one. perfect square, oh, another perfect square. And so we're going to write this one as the difference of squares, because I can write this as 4x squared minus 9 squared. So notice, difference of squares. And so I'm going to put a 4x here, minus 9, and a 4x plus 9. But once again, we need to recognize I have another, oh, wait a minute, should be squared, sorry, because we've got the fourth term here. Well, I need to recognize that I have a difference of squares here as well, because this could be written as 2x squared minus 3 squared. Okay, and then this is still 4x squared plus 9. And so I'm going to factor this first part again. So I'll have 2x minus 3, 2x plus 3, and then a 4x squared plus 9. Okay, so make sure you're looking out for those opportunities to write things as differences of squares, because once you get into this more complex examples, you're going to continue to have things you can take out and continue to have things that are going to be more reduced, or reduced more effectively. Okay. Okay, so another one. Here we're talking about cubes, and this is going to be a situation where you need to consult your formula. And so as you are looking at your formulas, and we're doing differences of cubes, we're going to factor, and remember that this is our A, and then if we want to rewrite the 27 as a cube so that we can easily see that. So we've got this is A and this is B. And so as I look at my formula, I'm going to go x minus 3 times x squared plus 3x plus 9, because I'm consulting with this formula. Let's look at another one. So when we're talking about trinomials, I know that you have talked about trinomials extensively in your time here. And so I just want to review a couple of examples. I am actually going to be using the asterisk method to work on these. And maybe you are adept at recognizing when you can factor things out. But I'm gonna approach this as if you've never, or you're just reviewing it and you're doing the trinomial formula that you have. In the middle here, we're going to put the product of the first term and the last term. So that's going to go on the middle in the top. And on the bottom in the middle, we're going to put the middle coefficient. So that's going to be my 8. And then on the two sides here and here, we're going to put two numbers that multiply to 16 but add to 8. So they multiply to 16 and add to 8. And then what's going to go on the top here is we're going to put the leading coefficient. All right? And so what you're going to see is we have two fractions here, and we need to reduce those. So I'm going to make this 4 over 1, and I'm going to make this 4 over 1. Well, those become my two factors here. Here's how it works. You take the 4 on top, and that becomes the 4 in front of the x, and then I've got plus 1 here. And then on the other side, it's the same situation. So in this case, we had a square situation, so both terms are the same, so we can rewrite it as 4x plus 1 squared. And like I said, maybe you recognize that first, but I wanted to show you how the asterisk method is going to work for this. When we look at the second one, we'll do the same method. And on top, I'm going to put that product of the leading coefficient and the constant, so that's going to be a 12. And on the middle, in the middle on the bottom, I'm going to put this middle coefficient. On the sides here, I need two things that are going to multiply to positive 12, but add to negative 7. And so that's going to be a minus 4, minus 3 situation. And that's going to be, just kind of knowing your factors. And then on top, I'm going to put my leading coefficient here of 1. Well, then we're going to have two factors, and that's going to give us the leading coefficient from up here, okay? And then I'll have the minus 4 goes in there, and then my leading coefficient on this one is 1, and then we're going to have a minus 3 situation there. So this is the factorization, and as I investigate it, I noticed that there's no other term. So this is these are prime factors of that trinomial. Okay, so that's how this works, and that's the basics of factoring. I know it's largely a review for many of you, and so I appreciate you watching, and we'll see you next time.